W1 and W2 with the subspaces generated by these given vectors respectively, and we need to find the basis and dimension of W1, W2, sum of the subspaces, and also we need to find the dimension of the intersection of the subspaces. So first, let's find the basis and dimension for the subspace W1, and W1 is generated by all these three vectors. So let B1 be the basis for W1, and writing all these vectors in a matrix form. To find the basis, we need to get the matrix A in echelon form. So for that, let's get the leading entry for the row 1. So I'm having -1 over here. That is the leading entry for the row 1. I need to make this entry to be as 1. So for that, we need to multiply the elements of the row 1 with -1. So applying the row operation, changing the row 1 and multiplying its element with -1. So we get row 1 to be as 1, -2 and -1. Writing the other elements as it is. So this is our leading entry. Next step is to make all these entries to be 0 which are below the leading entry, right? To get 0 in place of 2, just multiplying the row 1 with -2 and adding its elements to the row 2. So we need to change the row 2 by adding its elements to the row 1, but row 1 should be first multiplied with -2. Writing the first row as it is, and now changing the second row. So 1 multiplied by -2, we get -2, adding this to 2, we get 0. -2 multiplied with -2, we get 4, adding this to 0, we get 4. -1 multiplied with -2, we get 2, adding this to 1, we get 3. And then we need to make this to be as 0. So for that, just multiply the row 1 with 8 and adding this to the row 3. So I'm going to change the row 3 by adding its element to the row 1, but the row 1 should be first multiplied with 8. So 1 multiplied with 8, we get 8, adding this to -8, we get 0. -2 multiplied with 8, we get -16, and adding this to 4, we get -12. -1 multiplied with 8, we get -8, and adding this to -1, we get -9. So we have got all the elements below this leading entry to be 0. Right? Now for the second row, this is the leading entry, right? Try to make this as 1 and then making other entries to be 0, right? So to get 1 in place of 4, we just multiply the elements of the row 2 with 1 divided by 4. So writing the first and the third row as it is and changing the row 2. So row 2 needs to be changed by multiplying its element with 1 by 4. So 0 multiplied by 1 by 4, we get 0. 4 multiplied with 1 by 4, we get 1. And 3 multiplied with 1 by 4, we get 3 divided by 4. So now we get 1 to be the leading entry for the second row. We get 0 in place of -12. Just multiply the second row with 12 and adding its elements to the third row. Again, I'm saying that always take the advantage of the row containing the leading entry. Changing the row 3 by adding its elements to the row 2, but row 2 should be first multiplied with 12. And now 0 multiplied with 12, we get 0, adding this to 0, we get 0. 1 multiplied with 12, we get 12, and adding this to -12, we get 0. 3 by 4 multiplied with 12, we get 9. Adding this to -9, we get 0. So now try to get 0 in place of -2, multiplying the elements of the row 2 with 2 and adding this to the row 1. Please note that whenever you are applying the operations, the leading entries should not get disturbed, right? It should remain as it is, right? Okay, so we have got this to be as our echelon matrix. And I'm having the non-zero rows at the top of this matrix. So the basis for W1, that is B1, this is equal to, therefore, 1, 0, 1/2 and 0, 1, 3 by 4. that is a basis for W1. And how many number of elements are present in these bases? 2, right? So the dimension of W1 is equal to 2. Very fine. Alright. Let's move on to the second part to find the dimension for W2. So W2 is generated by these two vectors, and let B2 be the basis for W2, and writing these vectors in a matrix form, that is 1 0 0 and then 0 0 1, right? Now already I am having 1 over here, right? And there is also 0 below this leading entry. So there is no need to apply any row operation now here. In the second row, I am having the leading entry to be as 1. So this matrix is already in an echelon form. So just writing the basis for this now. So therefore, basis B2 is equal to 1 0 0 and 0 0 1. So these forms the basis for W2. And dimension of W2 is then how many number of elements? 2. So the dimension of W2 is 2 here. Alright. Now since W1 is generated by these 3 vectors, W2 is generated by these 2 vectors, then their sum is generated by all these 5 vectors, right? So let B3 be the basis for W1 plus W2, and writing all these 5 vectors in a matrix form. Starting with the leading entry of the first row, I'm having -1 over here. I need to get 1 in place of -1. How do I do that? Instead of applying any row operation, we are having the row 4 with the entries 1 0 0. So let's interchange the row 1 with row 4, right? Now in the next step, to get 0 in place of all these 3 entries. So for that, just multiply the row 1 with -2 and adding its element to the row 2, right? To get 0 in place of -8, again we have to multiply the row 1 with 8 and adding its elements to the row 3. Easy? Okay. Now to get 0 in place of -1. So for that, just multiply again the row 1 with 1 only and adding its elements to the row 4. And already we are having 0 over here, so writing this as it is. So below the leading entry of the first row, we are getting 0 0 0, right? Next step is to get the leading entry for the second row. And there is no leading entry for the second row because there is no non-zero entry present in the row 2, right? So let's interchange the row 2 with row 4, right? So now we are having 2 as a leading entry for the second row. I need to make this 2 as 1 first. For that, just multiplying the elements of the row 2 with 1/2. So now we are having leading entry to be 1 in the first row and leading entry to be 1 in the second row. Getting 0 in place of 4. So for that, multiplying the elements of the row 2 with -4 and adding these 2 elements to the row 3. So now we are getting all the entries to be 0 0 below and above the leading entry for the row 2. Next step, getting the leading entry of the row 3, that is -3. I need to make this as 1 first. So just multiply the elements of the row 3 with -1/3. So now for the third row also we are getting 1 to be the leading entry, right? Let's make these 2 entries as 0 now. For that, just multiply the row 3 with -1 and adding its elements to the row 4. Also same operation for the row 5th. And now it is remained to make this entry to be as 0 if possible. So for that, multiply the row 3 with -1/2 and adding its elements to the row 2. And writing the rest of the rows as it is. So now we are having the leading entry as 1 for the first row, leading entry as 1 for the second row, leading entry as 1 for the third row. So we are getting 3 non-zero rows which are at the top, and this is your beautiful echelon matrix. So therefore, the bases B3 are 1 0 0, 0 1 0 and 0 0 1. These are the standard bases, right? So the dimension of W1 plus W2 is equal to how many number of elements? It is 3, right? At last, we need to find the dimension for the intersection of the subspaces. And the result is the dimension of sum of the subspaces is equal to dimension of W1 plus dimension of W2 minus the dimension of W1 intersection W2. Just now we have calculated the dimension of W1 plus W2 to be 3. So writing here 3. The dimension of W1 is 2 plus dimension of W2 is also 2 minus the dimension of W1 intersection W2. So this is 3 equal to 4 minus the dimension of W1 intersection W2. Taking this to the other side, so we get dimension of W1 intersection W2 equal to 4 minus 3, that is equal to 1. So this is how we find the bases and dimensions for the subspaces. Alright, thank you. Stay blessed.